hours. So, okay, please ask your question. Who has the question?
স্যার হচ্ছে
Yes, Yasir.
এক্সারসাইজ 2
Exercise 2.
স্যার
Okay,
ইয়েস স্যার
exercise 2 of workbook, right?
ইয়েস স্যার
Yes, this one. This is actually two things
স্যার
here. One is
স্যার
yes, yes. Ask your
I
question
just
first.
I just confused in one part, that is uh, what is the next byte?
That will be sent.
Yes, sir.
That is
How can I
question
find what
C.
is the previous acknowledgement or
Okay,
previous
okay. You
sequence?
have to first draw a diagram to understand. See what is the next byte number that will be sent. Sent by whom? Who will send the next segment? Sender, right?
Yes, sir.
Sender will send the next segment. So this question is about basically what will be the sequence number of the next segment. Is it
Yes, sir.
right? So next byte number that will be sent, actually that basically means what will be the starting byte number, that is sequence number of the next segment. Which segment? The last segment sent by the sender was, you can see here. What is the last segment?
Sir,
950 with
sir,
500 bytes of data, right? This was the
but
last segment. Don't worry about the acknowledgement. This is the case for the sender.
but
So
sir,
sender send the last segment with sequence number 950, 500 bytes of data, right?
but
So what
এখানে
will be the next?
350ও এরপর থেকে পরে তো আবার 350ও পাঠাইছে, সো বুঝতেছি না, এখানেই
No, no,
কনফিউজ
no,
ছিলাম যে
no. 350 is not sent. Okay, okay. Let me.
Acknowledgement number.
Right, that is
স্যার এটা
acknowledgement number.
অ্যাকনলেজমেন্ট নাম্বার
So
হচ্ছে, এটা ছিল
acknowledgement is sent by whom? Sender or receiver?
রিসিভার।
Receivers. So sequence number segment is sent by the sender, acknowledgement is sent by the receiver. So there is no connection with these two directly. Indirectly these are connected. When you draw a diagram you will find, okay, sender has sent last segment. Just let me finish, then I can take again
ওকে
the question. Sender sends many segments. The last segment was from 950 to 500 bytes. Okay, now a segment is received, that is now the receiver sent an acknowledgement, that is 350. So what you can visualize, maybe sender had sent 10 segments, but receiver has acknowledged only the second one. It can happen because the other segments, for other segments acknowledgement will be sent later. So the relationship between these two is receiver has sent an acknowledgement number of 350. That means it is an acknowledgement for a previous, like one segment sent before, but there are other segments also for those no acknowledgement yet received. So these are two different facts you have to draw. Let me just try to draw it here. For example, to understand, if I draw the equation, the picture here, for example, the send base is 328, right? Previous send base was 328. Just this is the send base, so it is 328. Now the last TCP. So there are other segments sent, but this is the last TCP segment where sequence number was 950, right? So it is 950, and in this segment data sent is 500 byte. Okay, now it says a segment is received by the sender. So definitely it is the acknowledgement of a segment sent previously, that is not shown here. So you should draw the acknowledgement like this. This is an acknowledgement
Yes, sir.
for one
এখানে
of the
কনফিউজ
previous.
ছিলাম।
Okay,
লাইক
right?
অ্যাকনোলেজমেন্টটা যদি আমি একদম 950 এর পরে এঁকে দিই, প্রিভিয়াস থেকে আসতেছে না এরকম এঁকে দিই, তাহলে কিন্তু
That is confusing. That is confusing.
কনফিউজিং। ইয়েস স্যার,
That
ইয়েস
is
স্যার,
not logically correct. So
Yes, sir.
see, I didn't ask here in this question to draw the diagram, but if you draw the diagram, it will be clear to you. Okay.
Yes,
And
sir.
also another thing is sender and receiver will be different device. So sender is not seeing anything in the receiver, receiver is not seeing anything in the sender. Now see, now you see the questions. First one, what is the new value of send base? Since acknowledgement number is what 350 here, right? So what will be the send base? What will be the new value of send base? It will be 350, right?
Yes, sir.
Because this is the new acknowledgement, not new, latest acknowledgement received without earning up. So send base will be updated from 328 to 350. What is the last byte number that can be sent with certainty that receiver's buffer will not overflow? To understand that, you have to know what is the receiver's buffer size. You can see here window is 3000. So when it sends 350, in that case window equals to 3000. That means what? That means after receiving up to 350, the remaining free space in the receiver's buffer is 3000, right?
Yes, sir.
So what is the last byte number? That means what is this number?
3350.
Right, 3350. Just you add these two, you will get the last byte number. And what is the next byte number? Okay, now you come back to the sender. So sender has sent the last segment with sequence number 950 500 byte. So definitely what will be the next sequence number? That will be right 950 plus 500, right? If you add 500, that will indicate the sequence number for the next segment. Clear?
স্যার লাস্ট
Okay.
বাইটটা কি ছিল যেন ওটা মিস করে
Yes,
গেছি স্যার।
yeah.
Last one, which one?
বি
Question
নাম্বার
C?
কোশ্চেনটা স্যার, বি
C?
স্যার, বি।
B. Okay. What is the last byte number? Last byte number means see 350 up to 350 received, and then at that time more bytes free at the receiver's buffer is 3000. The question asks what is the last byte number that can be sent by the sender so that receiver's buffer will not overflow. So that means what? That means sender can send up to this point, right? This is the last byte number that sender can send. If sender sends more bytes, then receiver has no space to store, right? That will be overflow. So how you get this byte number? Just add 350 with 3000. So it will be 3000 plus 350. Basically, it will be the last acknowledgement number and the window. See, the window is 3000. So 350 plus 3000, 3350. That will indicate the last byte number sender can send so that receiver's buffer will not overflow.
স্যার,
Yes.
স্যার, সো হচ্ছে সি নাম্বার অ্যান্সার হচ্ছে লাস্ট অ্যাকনোলেজমেন্ট উইল বি আপডেটেড অ্যাকনোলেজমেন্ট উইল বি 950 plus 500, right?
This is not acknowledgement. This is sequence number. See, this is home. This is sent by
Sir.
home. Sender, not the receiver. So sender will send the sequence number, a segment with sequence number, and sequence number will be the previous, aligned with the previous segment, right? So previous segment started with 950 500 byte data. So the next segment by the sender will be 950 plus 500. Simple.
Yes,
Because
sir, yes, sir.
sender is always sending in sequence.
Yes, sir. Got it.
Clear? Okay. Let me let me remove this and go to one particular example, then we will go for the in-class assignment. So we have covered, in the last class, we have covered 3 primitive approaches of TCP congestion control, right? This is what we have covered in the last class. Okay, now what about AIMD? AIMD, there was AIMD, slow start, and then congestion avoidance. We have covered these 3. Just a review. AI means additive increase, MD means multiplicative decrease. So in AIMD, if there is no loss, all approaches in congestion control works like this. If there is a loss, reduce the rate. If there is no loss, increase the rate. So it's a continuous process. So in AIMD, if no loss, increase sequentially. That means from 1, then 2, then 3, then 4. And when there is a loss, make it half. Whenever there is a loss, if the current rate is, for example, 40, it will be 20. If current rate is 30, it will be 15, like this. Then there is a problem in AIMD. If we increase sequentially, it will take relatively longer time to reach the theoretical peak, because we don't know the condition in the middle. Definitely there is a theoretical peak that we can achieve, but that is not possible to know by the end system. That's why it continuously props. Props means if loss, decrease, if no loss, increase. So in slow start, the increase is exponential. The idea is we can reach the theoretical peak in a shorter amount of time. But again, in slow start, there was another problem, because it exponentially increases. In some point, it may jump from 64 to 128, from 120 to 256. So the more iteration, in the later iteration, we get larger and larger jump, and you can think about many nodes, many systems. So suddenly what can happen? Huge burst of packets may be lost, because it might cross the theoretical possible rate. So that is the problem with slow start. So in the last approach, congestion avoidance, we have used a threshold. What can be the value of threshold? That is one question. But before the threshold, it will increase exponentially. So it will reach the peak relatively less time. But after the threshold is reached, then it will increase sequentially, not exponentially. So that if a loss happens, it will not be a vast loss, not be a many number of packets lost at the same time. It will be smaller number of packets. That is the idea of congestion avoidance. So these were the 3 approaches we have covered in the last class. Then another thing, just keep in mind, we have read another, I think I have missed here. It is fast retransmission, right? We have read fast retransmission. Okay, sorry, fast retransmission. What is fast retransmission? It is, other than timeout, we can send data if we receive 3 duplicate acknowledgements before the timeout. Now, fast retransmission is not supported by all TCP variations. There are many variations. Some of those variations support fast retransmission. Some of those does not support fast retransmission. For example, in our textbook, we have 2 versions. One is TCP Tahoe, one is TCP Reno. These are simply variations of, like Windows 8, Windows 10, variation of Windows. TCP has some variations, TCP Tahoe, TCP Reno. Okay, now keep in mind, TCP Tahoe will not support fast retransmission. TCP Reno supports fast retransmission. That means what? That means if a version does not support fast retransmission, that means the only way for retransmission is timeout. So there is the difference. In case of TCP Tahoe, there is no option of 3 duplicate or fast retransmission. Always the only way for retransmission will be timeout. Okay, And in case of Reno, or in case of the versions where it supports both timeout and three duplicate, we have to know how the loss is detected. A loss can be detected after the timeout. A loss can be detected if three duplicate acknowledgements are received. So in case of timeout, for both slow start and congestion avoidance, in case of timeout, it will be again starting from 1 MSS. In case of three duplicate, it will be half. So just keep in mind, in case of timeout, if the loss is detected by timeout, loss is detected by if by timeout, that means rate. We call this congestion window, C window. It is actually the rate at which a node transmits. So rate will be again 1 MSS. 1 MSS. That is one segment in per RTT. Okay. 1 MSS per RTT. So that is the rate if timeout. Now if the loss is detected by three duplicate, that means what? That means we can retransmit even before timeout. So tell me, which case represents better network condition? Loss detected by timeout or loss detected by three duplicate? In which case we can tell that, okay, network condition is better?
The three duplicate.
The three
Very
duplicate.
good. Very good. Three duplicate. Because three duplicate means we don't need to wait for the timeout. That means somehow one segment was lost, but normally all the segments are received by the receiver, so that receiver is receiving multiple duplicate acknowledgements. That means network condition is better. If we need to wait until the timeout, that means network condition is not good. That's why in case of three duplicate, the rate, congestion window means the rate that we will decrease. It will not decrease much. It will be current rate, current congestion window divided by 2. Okay. So that means we will not decrease much, because if rate is 1 MSS, it will start from 1 again. But if it is C window by 2, current value by 2, then that means what? That means it will actually make it half and then start from there. And in case of congestion, avoidance, in case of I think in any case, the threshold that is used in congestion avoidance will be, we call this SS threshold. SS means what? SS means slow start. Since we actually change the slow start to include a threshold value, so that it will not be increasing exponentially after the threshold value. So whenever a loss is detected, SS threshold will be C window by 2. Doesn't matter whether it is timeout or it is three duplicate. So 3 things I have specified here, very important. If the loss is detected due to timeout, that means rate will be 1. Congestion window, rate is actually congestion window. If detected by three duplicate, it will be half. So you have to know by which case actually we detected the loss. But in any case, timeout or three duplicate, whenever there is a loss, the threshold will be changed. What will be the threshold value? It will always be changed to half. So congestion window by half. Doesn't matter timeout or three duplicate. Just a small example here. This is a scenario where all the points are given. These points are actually, you see, number of RTTs. So this is time in the x-axis, and in the y-axis, this is the rate. C window means what? Rate. So you can see at time 1, that means 1 RTT, the rate is what? 1 MSS. This is actually number of segments. 1 MSS means 1 segment. 2 MSS means 2 segment. And as slow start, we know it increases exponentially. So at time RTT2, it is 2. At RTT3, it is 4. At RTT4, it is 8. Then 16, then 32, right? And you can see initial threshold is set 32. How initial threshold is actually calculated, that depends. But initial threshold is 32, and then it increases sequentially. So 32, then 33, 34, 35, like this. And whenever there is a loss, see, during the loss, the congestion window was what? 40, right?
40.
40. So we have to know, actually the system will definitely know whether it is for timeout or for 3 duplicate. So we can have 2 types of questions here. We can have 2 types of thinking here. One is, if it is detected by 3 duplicate, then it will be half. See, the rate will be half, because in case of 3 duplicate, we said the rate will be half. And also whenever there is a loss, the threshold change. Initially the threshold was 32. Now what will be the threshold value?
20.
Again, right,
16.
40 by 2. 40 by
40.
2. So always SS threshold always will be half whenever there is a loss, and congestion window will be half if that is for 3 duplicate. Suppose after this point, now threshold is 20. Since threshold is 20, so already we reached the threshold, so it will again increase sequentially, not exponentially. If it became below the threshold, then it will increase exponentially. So it increased sequentially. And now again in RTT 22, you see 1 more loss. Now during the loss, what will be the congestion window? Again, you have to know how that is detected. Suppose this is detected by a timeout. So what will be the value of congestion window? See, again 1. Vice versa. If I say, okay, in this case, I ask you a question. Okay, in the RTT 22, can you tell me how it is detected? Now you see the congestion window is 1 MSS, right? So that means it was detected by timeout. So it is both way, it is true. Now what will be the SS threshold here? Anyone? Congestion window will be 1 because it's timeout.
Current by 2.
Very good. Current. So what is the current value? 24, right?
Yes.
When there is a loss, what is the current congestion window? 24. So 24 divided by 2, that means it will be, threshold will be 12. Since threshold is 12, but the value is below the threshold, so it will again start increasing exponentially. 1, 2, 4, 8. So this is the overview of this, and based on this, there are some questions here. Please try to solve these questions, and if you have a problem, we will discuss in the first 10 minutes in the next class. Then we'll go to chapter 4, because I have discussed all the possible options. So the questions actually just ask this. For example, identify the time periods when TCP slow start is operating. Just identify this one from 1 to 6, and another one, this one from 22 to 25, like this. So every concept I have already described. Go through this, and then in the first 10 minutes we will discuss in the next class. So it is almost, I think, over that 11:35. So please go to ELMS, download the question. You have very simple answers. You don't need to write many things. Answer is very short. Time is 20 minutes. I don't think it will take 20 minutes if you have a clear idea about TCP. And then there are 10 more minutes to upload. 10 minutes actually will not, because you might need 1 page, at most 2. 1 page should be enough. So convert to PDF and then upload. So 11:35 to 11:55, 20 minutes. And then you have 10 more minutes. You must upload by 12:05 p.m. Okay. So I think assignment sheet is available to download now. Please download and answer and then upload in the link. If anybody faces any question, you can ask me.
আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম।
স্যার আমি ফারাহ ফারজানা, ওই যে আপনাকে মেইল করেছিলাম লাস্ট উইকে,
ওকে
ওই যে অ্যাসাইনমেন্টের নিয়ে
আচ্ছা
আমার ইলনেসের ব্যাপারে।
ওকে ওকে ওকে
হ্যাঁ স্যার, আমি তো আজকের থেকে আবার ক্লাস রিজয়েন করছি, তো আই ডিডন্ট নো অ্যাবাউট দিস কুইজ। এখন আমি কি করতে
ও
পারি?
um actually we'll take 3 out of 4.
হুম
You
হুম
you did not attend the TCP classes, right?
হুম হুম
So
না, লাস্ট 2 weeks I couldn't attend the classes.
okay, no problem. Then I think just attend the remaining assignments and
হুম
then
হুম
we'll see what we can do. Okay.
ওকে স্যার, থ্যাংক ইউ
Okay.
স্যার।
Thank you. Okay, I am I am sharing this in the screen. If you- Okay, okay, all of you have able to download, right? Okay, thank you.
Sir, I have a question, sir.
Okay, Ishtiyaq.
Sir, in your first question, second number, like you just asked that describe what will happen after the first timeout interval. Sir, is it the full happening moments like after the total time interval or the between time interval?
After the first timeout interval. First timeout. Only after the first timeout.
Okay, sir. Then okay, sir. Then okay, sir. Then, sir, after the first time interval, what will be happen in the transmitting communication, right, sir?
Right, right. You can draw and
Okay, sir. Thank
write
you,
a
sir.
one line explanation.
Okay, sir.
Okay.
স্যার স্যার
Yes.
স্যার হচ্ছে এই কোশ্চেন 1 এর 2 তে কোথায় ইন্টার টাইম আউট হবে এটা তো বলা নাই তো হচ্ছে স্যার হচ্ছে
Assume
টাইম আউট
yourself any timeout. Just assume a reasonable timeout. There must be a timeout, right?
ইয়েস স্যার
Just assume a timeout
ওকে স্যার
anywhere. Don't worry. In any case, you have a timeout, and then accordingly you have to answer.
স্যার টাইম আউট যদি ধরি অল অ্যাকনলেজমেন্ট পাওয়ার পরে বা
Timeout is not dependent on acknowledgement. Okay, so you can assume any timeout after acknowledgement, before acknowledgement. Acknowledgement is not related with timeout. Timeout is sent by the sender, acknowledgement is sent by the receiver. So those are different. Any timeout you can assume and then answer
Okay, sir.
accordingly.
Okay.
Okay. Priyobroto, are you there? Priyobroto? Ali Ahmed Khan? Rakibul Islam? Tanvir Hassan Imon? Khondokar Jahidul Islam? Khalid Ridwan Mobin? Mohammad Mahfuzur Rahman? Sudeep Sarkar? Abu Abdullah? And Rifaz Nahian? You all are absent. Oh, Rifaz is there, right?
স্যার মাহফুজুর রহমান স্যার
Mohammad Mahfuzur Rahman.
জি স্যার
Okay, okay. Rifaz is
স্যার
there.
এমডি খালিদ রেদওয়ান স্যার
Khalid Ridwan. Okay.
Sir, Rifaz, sir.
Rifaz, yes.
Government school.
Rifaz present. Okay.
Sir,
Yes.
sir, first B number question এ আপনি বলেছেন illustrated with corresponding TCP connection management function. স্যার এটা কি এই তিনটা ফ্ল্যাগের মানে হেডারটাকে ড্রয়িং করে দেখাবো স্যার?
You don't need to draw. You just explain briefly. You can
Oh,
draw
okay.
also. No problem. You can draw. No
Sir,
problem.
but drawing is mandatory.
No, no. Drawing is not mandatory.
Okay, sir. Okay, then it will be done, sir. Okay.
Okay. Those who will finish and upload, just write down done in the message box. Okay, that will be good. Your initial time is up. 20 minutes time is up. Now you have 10 minutes to scan and upload. After uploading, write done, and then you can leave.
স্যার আমার রোল কল করা হয় নাই।
Misbahul Alam. Those I did not call present.
ওকে স্যার।
So you are also present.
স্যার প্রিয়ব্রত নাথ।
Yes, Priyabroto. I got your message box.
স্যার সুদীপ সরকার।
Shudip. Okay. So Abu Abdullah, then Khandokar Jahidul, Tanvir Hassan Imon, Rakibul Islam, then Ali Ahmed Khan. These only absent. These are absent. Okay.
স্যার নাম্বার 2 তে কয়বার ডাটা পাঠাবো সেটা তো কিছু স্যার উল্লেখ করা নাই স্যার। নাম্বার 2 স্যার।
Number 2.
জি স্যার।
No, it you have to answer this. What will happen? Oh, number
আচ্ছা,
2.
জি
Question
স্যার।
number 2 or
কোশ্চেন নাম্বার 2 স্যার, কোশ্চেন নাম্বার 2।
question number 2? Just specify x, y, z. Just what are the values of x, y, and z according to the diagram? You have to give the values only.
স্যার আমি বাইট মানে কয়বার ডাটা পাঠাইছি, কতটুকু রিসিভ করছি সেটা আমি
No,
না
no, no.
জানলে।
You don't need that. The information given in the question is enough
ওকে স্যার।
for deciding with x, y, z. You don't need any other information. So please complete and upload. 6 minutes left to upload. So if you try at the end, then it will be again congestion and some of you might miss the deadline. So don't take too much time. Scan and then upload. Okay, those who are done, you can leave. No problem.
আসসালামু আলাইকুম স্যার।
Walaikum assalam.
স্যার আমি নেট প্রবলেমের কারণে অ্যাটেন্ডেন্স দিতে পারি নাই স্যার।
Rokono Jaman. No, I gave you attendance present. Okay.
ইয়েস স্যার।
Okay, no problem.
স্যার আমি না সাবমিট করতে পারতেছি না, আমি কি মেল করতে পারি?
No. Try uploading. Those who are done, you can leave. Just after uploading, Alaikum Assalam. After uploading, you can leave.
স্যার আপলোড কি দেওয়া যাবে এখন?
স্যার ক্লাস নেবেন না চলে যাবো?
Okay, we will end at 12:10 p.m. So please upload, and then before you leave, upload the assignment in the ELMS. So we'll finish at 12:10.
স্যার আমি প্রেজেন্ট দিতে পারিনি।
You are present, no problem. I have already taken the present. Okay,
ওকে
you
স্যার
are
থ্যাংক ইউ
present. Okay.